This is 2021 question 4, connected particles, part B. A smooth wedge of mass 4m and slope 30 rests on a smooth horizontal surface. A particle of mass m is placed on the smooth inclined face and released from rest. A horizontal force F is applied to keep it from moving. Say it's here. And we're asked to show in separate diagrams the forces acting on the wedge and the particle. Okay, let's see what's happening here. So the wedge is not moving, so we have this mg coming down, mass of m, so we have mg, and it's a force R between the particle and the wedge. That force R will come down this way, and we have the wedge itself with an angle of 30. We have a reaction or coming down this way. We have another reaction between the wedge and the surface, which we'll call S. We have 4 mg coming down, its mass, and we have this force stopping it from moving. So the force is stopping it from moving. Let's see, we're asked to find F in terms of m. So F has to be equal to, if it's not moving, whatever's going on in this direction. So let's just do another little diagram. So we have 30 in here. If we have R coming down this way, we drop a perpendicular here. R will be the hypotenuse, and we have another 30 in here. So on this side will be R sine 30. Going in that direction. F is stopping it coming in this direction. So it's not moving. F is equal to R sine 30. So F is equal to R over 2. What else can we say here? So let's take the particle. See what's happening here. Or we have mg. We're going to have mg cos 30 and parallel to the slope mg sine 30. Now in a minute we'll be looking at accelerations. It's going to go down the slope with an acceleration of p. The wedge is going to move this way with an acceleration of q. And we're going to need to find the acceleration in this direction and perpendicular in that direction there. That's perpendicular, so we have q here, we have 30 in here, we have 30 in here. So along this side we have q cos 30, and here we have q sine 30. For now, there's no acceleration in this direction. The only thing that's happening is the particle is moving down the slope with the wedge not moving. So it's moving with an acceleration of p. So what we need to do, the next equation we're going to have is mg cos 30 when it is moving minus r is equal to ma. But when there's no acceleration here, we can say that this r initially not moving with the wedge is going to be equal to mg cos 30. So r when the wedge is not moving is root 3 mg over 2. And we bring that up into F, we're going to get the force stopping it moving then is going to be R over 2. So root 3 mg over 2 times 2. So that's the force that's stopping it moving. Now it's going to be released from rest. So we have these forces and these accelerations for the particle. So we'll only have 2 equations for the particle. So let's see what they are. So let's start with going down the slope. It's going down the slope with an acceleration of p. But now opposing it is this acceleration of q cos 30. So the acceleration is going to be p minus q cos 30. So we're going to have going down this mg sine 30 minus what's opposing it, which is nothing. This is going to be the m times a, which is p minus q cos 30. We'll tidy them up in a minute. I think it's easier to see them with the sine and cos written in. The second equation is going to be the acceleration in this direction, so perpendicular to the slope. So perpendicular to the slope, we're going to have this r now, and we're going to have the mg cos 30. So first of all, it's going to go down, so it's going to be mg cos 30 minus the r will be equal to the ma that we set above here, m times a in the perpendicular direction, q sine 30, mq sine 30. And then for the wedge is moving in this direction with an acceleration of q. And we looked already at the force in that direction, it was r sine 30. So r sine 30, there's nothing opposing it. R sine 30 is equal to ma. M is 4m and a is q. So r over 2 is equal to 4mq. R is equal to 8mq. We're asked to solve. What are we asked for here? Find the value of p and the value of q. We need to solve for both. Okay, so let's start tidying them up now. We have this equation, so we can sub r in if we want. Let's sub r into the second equation here. Mg times root 3 over 2 minus 8mq is equal to mq over 2. Multiplying by 2, I'm going to get root 3 mg minus 16 mq is equal to mq. I'm going to divide by m. I'm going to get 17q on the right hand side, q plus 16q. And on the left hand side, where's my q gone? It's over here on the left, so I'm going to get root 3g. So I want q, so q is equal to root 3g over 17. And then to solve for p, that'll be a simple equation for p. Just use this one here. So mg sine 30, mg over 2 is equal to, we can actually divide by m here, cross that m out. G over 2 is equal to, so we cross these m's out, is equal to p minus q by the cos of 30, so minus q root 3g over 17 by the cos of 30, which is root 3 over 2. So g over 2 is equal to p minus 3g over 34. So this will be, to get 34 on the bottom, will be 17g over 34. So we're going to get 17g over 34 plus 3g over 34 is p. 20g over 34 is p. So p is equal to 10g over 17. And these will be in meters per second ms to the minus 2, or meters per second squared.